Okay, we have something called the polyatomic ion chart. We can do Vsepr with the polyatomic ions. It's going to be the same procedure. It's just going to be one added thing you're going to have to kind of look at. So let's go ahead and do one of the polyatomic ions, which is called nitrate. Well, again, we go through the same process. We look at nitrogen. We look at oxygen. We look at group 15, 5 valence electrons. Group 16, 6 valence electrons. And then we start drawing our structure. Again, N is the smallest amount and will become your central atom. We go through the same procedure on this. You're going to be amazed. We always do this. Okay, so you're going to see we have something that kind of looks like this. Now we have to be always paying attention at this because we want to make a negative charge. So if you recall the previous videos, when I said a -1 doesn't work, it's because I was dealing with a neutral charge. This one's a negative charge. So what I'm going to do is I'm going to deal with the outers first. I'm going to have one line and 6 dots, which equals a -1. I am happy with that because, again, I'm looking at this one here. So this part can be a -1. Now all I have to do is make my other two equal to 0. I don't want to get another -1 in there. So now I've got my two other oxygens which I want to make equal to 0. Okay, how am I going to do that? Well, we know that this one is 7, but if I do this, it makes it equal to 6 because I have 2 lines and 4 dots. So that works. How about this one? Do the same thing. So you're going to actually notice that this one is actually an expanded octet. Now let's take a look. Again, I'm going to write my zeros out here just kind of to show the charge of those formal charges. And I'm going to look at the central one. I have 5 lines. Do I want any dots? No, because I want the central one to actually be equal to 0. And that's another common characteristic of this. We actually will make this equal to 0 because that's what I want my central atom to be. And besides, I already have my -1 charge here. So what happens like if I change this out? Oh, by the way, this is going to be nonpolar. No lines, or no dots around the central atom. Let's change this out a little bit. Make this another polyatomic ion, which is actually called the nitrite ion. Now you can kind of see what I'm doing here. I'm going to keep these numbers up here. I'll draw it like this. I'll make these like this. Again, common procedure for outer atoms. I take care of the outers first. You're going to notice that this one actually meets the qualifications of the top one for the oxygens. So I'm good with the -1. It matches up. I'm good with that. How do I make this one equal to 0? I do this, and now it's the bottom one. Again, it's the common procedure for that. Now, what about the nitrogens? Well, you got to remember that this is slightly different, so the structure is going to be slightly different. So you're going to notice right now I have 3 lines. What's going to make this equal to 0? Because I want my central atom to be equal to 0. Well, I'm going to have to add 2 dots. And that equals, oops, not 5, that higher level math, 0. So this is going to be this. That's going to make it polar. Now there's going to be another problem with this. These guys affect what this is going to look like. Because we have something called repulsion, which is part of the name for Vsepr. It's called valence shell electron pair repulsion. So it's going to kind of look now like this. Again, these dots here, actually the reason why it's called polar is because it affects or messes up with your bonding angles. Let's go ahead and do another ion. You can pretty much do it with all the ones there. You have ones that are kind of a little different. We're not going to really deal with those. Well, there is one that's kind of unique. This is called acetate. And we'll do a charge of this, and then we'll go to maybe a -3, just to show you how that works out. Now I'm dealing with this many formal charges. 14, group 1, group 16. That looks like that. You're going to say, well, I don't know what the central atom is for my carbon. Or oxygen. Now, carbon always likes being central, so if you have a situation like this, C is always going to be the central. So it's going to look like this. And it's going to look like this. I would suggest just drawing it in a line. Then we're going to deal with the hydrogens. Let's go with this. Let's see. You may have to play with the structure a little bit. I'm going to put an H here just to see if it's going to work. The H's are my outers. Again, H is always happy with one line. I don't want any dots because that's going to mess up with that 0, and you put dots with these. That doesn't ever happen. So we know all these guys are going to be 0 charge. Now let's deal with the oxygens. Those are my outers. I've got 2 here, so I'm going to draw 4 here. And now I'm also going to draw 4 here. The reason why I did that is because I have 2 lines and 4 dots. And I've got it on both of them. Now the problem is, if you're kind of taking a look at this, it doesn't work out too well because we want the inners to be 0, and we're not going to have that -1 charge that we need. So what we're going to do is say, well, I made a little mistake here. And I'm going to have to move my hydrogen here. Now the problem, again, that we're going to fall against is that. Because I'm going to have 3 lines and I'm going to have 2 dots. Now I could add 2 more here, but it's not going to work out very well. I'm trying to remember the structure of this because it's a little bit different. So let's go ahead and do this and put 2 dots. So sometimes you have to play with the structure on that. That's going to be 4 lines and 2 dots. It still doesn't work. I have to try to get that as a negative 1 charge. So again, you have to play around with the structure again. It does work out. So we're going to put my hydrogens all here. And hydrogen's really attracted to oxygen anyway. Okay, so now I have to make 6 dots, or 6 lines, make it equal to 0. And then I can mess around with this one. Uh-oh, look at what we're doing. Again, we're not going to look at these numbers over here. That got us started, but again, this might be a little bit confusing. We'll take a look at our carbons on the side, but now we have something that looks like this. Now we know this is a negative 1 charge. Now all I have to do is make those carbons equal to 4. So if we're going to go with the 4, this one's already happy. We're going to have to make this equal to 4, so that's what we're going to have to do. Now both of my carbons are 4. Now you notice this one is actually not going to work. I still want a negative 1 charge. I actually have more of one now. Let's get rid of these 2 dots. That's going to equal my 7 that I need. 1, 2, 3, 4 dots. That's 7, negative 1 charge. Now I have everything in here equaling 0. And this is actually an acceptable one for this. Just to make them all equal to 0, except for the one on the left with a negative 1 charge. Another thing to kind of remember is, since carbon's my central atom, a whole lot of times it's not going to have, it's always going to be a central atom, carbon. So that's the reason why it's here. We could also draw this in many different ways. I can move my hydrogens over here. That's what we call an isomer. And an isomer is the same structure, and you can draw it separate ways. So when we talk about isomers, it's just, you can arrange them differently. We really can't call it anything else. It is called an isomer, and that's kind of like organic chemistry. Let's go ahead and do one last one. Let's go with the larger charge. We have P, we have O. Hopefully I didn't confuse you on the last one because I had to play around with the structure. Again, they eventually work out if you have it on the polyatomic ion chart. Sometimes they just won't ever work out. I will not give you ones that are going to cause that type of a problem. Again, P, central, O, 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 O. Nice part about oxygens are you can do the same procedure, and you can easily change it from a negative 1 charge to a neutral charge. So now I want to have 3 that are going to equal a negative. Well, we already know that this one's going to equal 7 because I have 1 line and 6 dots. So it's a negative 1. Negative 1, negative 1, negative 1. So now that equals a negative 3. I want to change this to a neutral. So now I've got 2 lines plus 4 dots, which equals 0. So now I took care of this one. And my phosphorus I want to equal 5. You're going to notice that in my central atom I actually have 5 lines plus 0 dots. And that equals 0. Is it polar or nonpolar? Well, around the central atom, it is nonpolar because I have no unpaired electrons. It is the octet rule, or the expanded octet rule, because it's 2, 4, 6, 8, 10. So that's how you draw ones that are ions. And again, it's very important to go from the starting one to this one so you can understand this one.